So here's a problem. Find the differential coefficient of this function, and then find the value of the differential when x is 1.5. I've plotted the function. Here it is. So you can see it goes towards 0 away from when x gets large, but when x is small, we get some really big values for y. And the gradient of this function has a whole range of values. When we differentiate, remember, we're finding the gradient. So when x is large, the gradient is going to fall to quite small values, but it'll be large here near start. We want to know what it is when x is 1.5. So if that's 6, then that must be 1. So 1.5 around here somewhere. So it's around this part of the curve. We're going to try and find the gradient. This is if we look at the function, what we have here is a different situation. Last time we had two functions, two parts to the function, but they were multiplied together. Now we've got two separate functions, 4 sine 5x and 5x to the 4, but they're divided by each other. So now we use something called the quotient rule. So to differentiate this, we use this thing called the quotient rule. Look at the next slide. And here is the rule. Like the product rule, it looks quite awkward. And we use that to differentiate this function. The first thing we do is we let one bit be u and one bit be v. Now, in the product rule, it doesn't matter which is which, but in the quotient rule, it's very important that the bottom function is always the one we call v. So the denominator, the bottom function, is the one we call v. The numerator is u. And this rule, stated in words, is this, look. To differentiate, you multiply the bottom function by the differential of the top function and subtract, that's what that's saying here, look, subtract the top function multiplied by the differential of the bottom function. And then finally, this is the difference to the product rule, we divide the whole lot by the bottom function squared. So in words, that's what we're going to do. So it's a bit more long-winded. And when we get to the simplifying bit, it takes a little bit more time to simplify it, and the algebra might look a bit awkward to you. But again, bear in mind, so long as you're following the rule, you should be okay. So let's try it for this example. So if you go to the next slide, here it is again, and we're going to try and apply this quotient rule to it. So if you've got to do this to differentiate, I've got one function divided by another. I call the top function u and the bottom function v. So I've done that in this example. As for the product rule, we take each part, so we take the top bit and differentiate it. So if u equals 4 sine 5x, du by dx equals so if u equals 4 sine 5x du by dx, using this table of differentials here, looking at the sine one, so the a comes out and goes in front and the sign changes to cosine. So the 5 comes out, times by the 4 in front is 20, and the sign changes to a cosine. So the u by dx becomes that. The second one, dv by dx, using the relevant rule on the table, and this is the general rule. The power comes down and multiplies by the number in front, so 4 5s are 20, and I take one off the power. So the differentiation bit is easy if we know the table. You just write down the answer. Now, as before, if you're doing this in the assignment, I want you to state the rule. There it is, the quotient rule. And then we apply it. So dy by dx, and make sure your y's look like y's and your u's look like u's and your v's look like v's. I think it's a shame that they used y, u and v, because if you're not careful they can look the same. So v, what's v? Well, v is 5x to the 4. So 5x to the 4. What's du by dx? We've differentiated du to get 20 cos 5x, so that's what goes here. So that's that first bit done. And then we take away u, which is 4 sine 5x, times the differential of v, which is 20x cubed. So that's the second bit done. All we're doing is putting these values into this rule, into this quotient rule. And then it says divide the whole lot by whatever v is squared. So that's 5x to the 4 squared. So write 5x to the 4, put a bracket round it and square the whole lot. I want to simplify it. I want you to have a go at simplifying it too. Look at it. Look at this first term. I've got 5 times x to the 4 times 20 times cos 5x. 4 things multiplied together. I can do the 5 times the 20. That's 100. Look at the next one. 4 times the sine of 5x times 20 times x cubed. I can do the 4 times the 20. That's 80. And I'm going to make sure also that the sine bit's at the end. So I'm going to put that at the end instead of the 20x cubed. And this one, I can square this. Look, 5 squared is 25. X to the 4 squared is x to the 8. So I can write 100 x to the 4 times the cosine of 5x minus 80 x cubed sine 5x. So I tidy that top bit up and then I divide that by 25 x to the 8. Now comes an important algebraic step. I've got on the bottom here x to the 8. I've got x times x times x, 8 times x to the 8. And I've got some x's on the top. I can't, as it stands, cancel this into these because they're added or subtracted. I can't do that. But what I can do if they're multiplied together. So factorizing the top is going to be important because I can then do some cancelling. So looking at this top, what's common to both? Well, 20 goes into 80 and 800, so I can take 20 outside. And x cubed, I could take x cubed outside because I've got an x cubed there and an x to the 4 there. So I can take 20 x cubed outside a bracket. And then I think about what have I got left. What have I got to times that by to get back to the first term on the top? 20 times 5 is 100. Yep. X times x cubed is x to the 4, so that gets us back to that. And then the cos 5x. The next one, 20 times 4 is 80. I've already got the x cubed, so I just want the sine 5x. Over 25 x to the 8. Now, if we look at this, I've got one term multiplied by another, this whole bracket, over something else. So now I can cancel. I can look at this and do some cancelling out. 5s goes into 24 times, and 5s goes into 25 5 times. So I can replace them with a 4 and a 5. I've got x cubed on the top and x to the 8 on the bottom, so I can cancel out those 3 x's on the top with 3 of the x's underneath, leaving just 5, so I can change that to a 5. So that means, finally, the differential is 4 brackets 5x cos 5x minus 4 sin x over 5x to the 5. And that would be my final answer for the differential. Final step in the assignments once you've found the differential, you're going to be asked to remember this question. The question was, find the value of the differential when x is 1.5. So finally, when x equals 1.5, we put values in. Now, for these functions, trigonometric functions, invariably, we're going to be working in radians. And so you make sure your calculator's in radians. Use the fraction button and literally put this on the top. 4, open bracket, 5 times 1.5, because x is 1.5, times the cosine of 5 times 1.5. Don't forget to close the bracket after you've done the cosine, minus 4 times the sine of 1.5. And then underneath, 5 times 1.5 to the power 5. You can put it in one hit in your calculator. So when x equals 1.5, the differential is, put it into your calculator and see what you get. So putting the numbers in, we get this, and putting them into the calculator gives us, putting numbers in, we get minus 0.12. Check you do that right. That's the final stage, of course, and we've got a few answers around the room, so do it a couple of times. Try not to put too much into the calculator. You know, do little bits in your head if you can. You know what 5 times 1.5 is, so you don't need to put that into the calculator, and so on. Help yourself by doing a few less steps. Okay.